The curve with equation y equals 63 over 4x minus 1 is sketched below for x between 1 and 16 inclusive. The function f is defined by f of x equals 63 over 4x minus 1 for x between the 1 and the 16 inclusive. Find the range of f. The inverse of f is f minus 1. Find f minus 1 of x. Solve the equation f minus 1 of x equals 1. The function g is defined by g of x equals x squared for x between minus 4 and minus 1. Write down an expression for f of g of x and solve the equation f of g of x equals 1. So that's the question then. So let's have a look at it here. Okay, the first thing to do is find the range of f. 63 over 4x minus 1. From the picture we can see the highest value is here. The lowest value is at 16, highest value is at 1. So f1 and f16 will give us the range. So f of 1 then is equal to, now it's 63 over 4x minus 1, isn't it? Let's just check that. Yeah, there it is there. So input 1, 63 over 3 is 21. And f of 16 is equal to 63 over 4 times 16 minus 1, which is 63. 63 over 63 is 1. So range of f is equal to, well, because it touched 1, it touches 21. Because it touched 16, it touches the value 1. So it's from 1 to 21 inclusive, i.e. y varies between 21 and 1 inclusive. So there's our range for part A. Find the inverse. Okay, so B, well, we know y is equal to 63 over 4x minus 1, so let's rearrange it then. More than one term, put a bracket. Let's move this up to times. And at the same time we'll move the y down. So 63 over y. So 4x is equal to 63 over y. And move the 1 over to plus 1. And then divide all the way through by 4. 63 over 4y plus 1/4. So I've divided everything all the way through the equation by 4. Now we can write the inverse function. F minus 1 of x then. Swap the symbols around. 63 over 4x plus 1/4. So there's the inverse function. Okay, solve f minus 1x equals 1. So that was part 1. Part 2. Here. When does it equal 1? Well, we actually know that because when it equals 1, the x value will be 16 from the graph, won't it? But we can, it tells us to solve it, so we'll put it in here. Equals 1. What does x equal? So, well, this is interesting because I'm not going to get 1 here. So f of x, find f of 1 and solve f minus 1x equals 1. So when does y equal 1? Should be x is 16. Okay, so here 63 over 4x then. And we move the quarter over. 1 minus a quarter is 3/4. We can invert both fractions. So 4x over 63 is equal to 4 over 3. So we can cancel by 4 all the way through. X is equal to 63 over 3. because we moved this up and we cancelled by 4 both sides, and that's 21. So my thought about 16 was completely wrong. X is 21. Okay, X is 21 then. Okay, good. There it is. F of 1 is 21, sorry. There it was. So the inverse will be 21. I was looking down here and I should have been looking here. F minus 1 of 1. Okay, so that's that done then. X is 21. So that's part 2. G of x equals x squared between minus 4 and 1. Write down f of g of x. So f of g of x, just write it down, it says, which is f of g of x, which equals f of x squared, isn't it? And that's equal to f takes something to 63 over 4 times something minus 1, isn't it? 63 over 4 times something, which is x squared in this case, minus 1. So there's f of g of x, part 1. Now I'm going to switch back up and read part 2. Solve f of g of x equals 1. So part 2 then. So here, 63 over 4 x squared minus 1 equals 1. Move this term up to times. You can see what x is going to equal, can't we? So 4x squared is equal to, move the 1 over to 64. X squared equals 16. So that tells us, so x square root equals 4. There's no negative because this the domain. X equals 4 is the value. Because x was not defined, g of x is not defined on the negative. It's only defined between 1 and 4, wasn't it? Let's have a little look. Oh, minus 4 to 1 is g of x, so the answer must be minus 4 because that's the only possible solution. Not 4 because it's not in the domain of x. See a g of x? So when we let it equal 1, the only x's we can allow are minus 4 up to 1 as solutions. So x equals minus 4.